Hey everybody, so we're going to work our way through this activity sheet here. We're going to classify some real numbers, and I like this one because it starts with the Venn diagram already pre-made for us. But there's a few changes I want to make right off the bat. So you'll notice that they don't have a natural number set, so put natural in here. So there's natural, whole, integers, then rational, irrational, all real. Just add that, and then we're good. All right, so let's look what we got. We said write each number in the correct location on the Venn diagram for the real number system. Each number should be written only once. So -6, that is an integer, right? So -6, 2 and 73/100ths, that can be written as a fraction. So 2 and 73/100ths, we're going to check these off as we go. 3/7, well, that is a fraction, so that is a rational number. Square root of 2, that cannot be written as a fraction, therefore it is irrational. Square root of 9, that's actually 3, so that would be considered a natural number. Oh, hold on a second. I had to check myself there because I don't know why, but I was just feeling like I had to check it. Yeah, it's just because it's written as a radical here, it's all about the simplest term, which is 3, so therefore it is here's a different color here. That would be considered a natural number. Okay, which is also a whole number, but we're going to call it a natural number. -100, that's definitely an integer, -100. And 0 is a whole number. Pi, that's irrational. 1, that is a whole number. Sorry, that is a natural number. It's also a whole number as well, but we're going to have the subset natural. -1/2, that is a rational number, because it's written as a fraction, obviously. -3 and 8/10ths, that is a rational number. 5 and 42/100ths, this is repeating, therefore it could be written as a fraction. So 5 and 42/100ths repeating. This, however, is not repeating. This goes on with no discernible pattern, therefore that is an irrational number. You could not write that as a fraction. So 8.23017, Okay. So that's how you'd classify all of those. Hopefully that answers some questions we have. Now let's check the true or false. All whole numbers are integers. Well, let's take a look. Oh, hold on, let me zoom out a little bit here. Not that far, hold on. Are all whole numbers integers? Well, yes, because look, the whole number is that number set is a subset of integers. It's fully enclosed within integers, so yes. And the explanation, whole numbers are a subset of integers. And if you're wondering what subset means, it just means it's a set contained within another set, right? Think in terms of football. If you guys watch NFL football, right? The AFC East is a subset of the AFC. So that division, right? The 4-team division, the AFC East, which is, what does that consist of? AFC East has the Dolphins, the Jets, the Patriots, and the Bills, right? Those 4 teams, they create the AFC East. The AFC East is a subset of the AFC itself, right? Because there's 4 divisions in the AFC. Okay, all integers are whole numbers. No, that is not the case because they have negative terms that are not. So no. And we don't need to explain that one. Some rational numbers are integers. Some rational numbers are integers. Yes, that's the case because look, integers are a subset of rational numbers, but not all rational numbers are contained within it. So yes. Some whole numbers are irrational numbers. No, there's no there's no mixing of these two sets of data. You can see they're not mixing together. And actually, think about it this way. Irrational, by definition, are numbers that cannot be written as fractions, whereas whole numbers can always be written as fractions, so nope. All right, hopefully that clarifies that. Let's look at the other side. So let's see what we got here. Let's zoom in a little bit. List the numbers in the set. Okay, so 4/5. We're going to write each number once. So I guess, no, we can do it more than once, I guess. 4/5 is not a whole number. It is not an integer. It is a rational number. It is not irrational. It is a real number. So that's what we'll do. We'll go through it. -18 is not whole. It is an integer. It is a rational number. And it is a real number. 0 is a whole number. It is an integer. It is a rational number. And it is a real number. Radical 5 is not whole, it's not integer, it's not rational. It is irrational because it cannot be written as a fraction, and it is real. These are all going to be real. I would assume I have no imaginary numbers up here. -1/2, nope, not whole, not an integer. It is rational though, because it's written as a fraction. That's the definition of a rational number. -1/2. Negative 2 1/100th, so that's not whole, it's not integer. It is a rational number, though, because it can be written as a fraction, and that is a real number. 5, that's a whole number. It is also a rational number. It is also a rational number, and it is a real number. Look at that, it's almost all of them. Pi is going to be irrational and real. I'm running out of room here. So this could be written as a fraction. We know this because it's a repeating decimal, so that's going to be rational and real. And this cannot be written as a fraction because there's no discernible pattern, therefore it is going to be irrational. So let's see if I can write this whole thing without screwing it up. I think I did it right, and then I'm going to write it down here too. 2, 3, 1, 5, 9, ... Okay, so this is kind of like what we did on this side, just written a little differently. All right, please place a check mark for each set that the number is a part of. So negative 7 is not whole. It is an integer. It is rational. It is not irrational. It is real. 3/4. It's definitely not a whole number. It's not an integer. It is written as a fraction, and it is real. Radical 2. Well, it's irrational because it cannot be written as a fraction, and it is a real number. 5 is definitely a whole number. It is an integer. It is rational, and it is real. This one cannot be written as a it can be written as a fraction, and it's real. And that's it. Okay. Now here's the toughest part, I think, actually. So hopefully I don't screw this up. All integers are rational. Let's look. It's actually easy to go back and look. So integers are all within the rational symbol, so yes. If a number is rational, then it is a whole number. So just because a number is rational doesn't mean it has to be a whole number. There's actually plenty of numbers over here that are not whole. So it's going to be no or false. I guess this should be true. Oh, let me scroll down here. Some irrational numbers are integers. I don't think so. Let's take a look. So integers do not overlap there, so nope. Absolutely not. You can see where the usefulness is of the Venn diagram, especially with problems like this. All irrational numbers are real numbers. Well, let's take a look. All irrational numbers are, yeah, it's a subset of the real numbers. So yep, that is true. No whole numbers are integers. That is actually the opposite. All whole numbers are considered integers. You can see that they're completely contained within the integers set. So whole numbers are a subset of integers. That's false. Okay, so that finishes that activity. Hopefully this clarifies any questions you may have had on this. Let me know if you have any questions. Thanks, guys.